input-output devices. So we've talked about the motherboard at this point. We've talked about memory at this point. We've talked about processors and the BIOS. Now we're going to move into all the things that touch our computers to either give us input into the computer or get output from the computer. So we talk about our input and output devices. These are the things that are going to send information to and from the processor and the memory. The most common on recent systems is obviously the Universal Serial Bus or USB. In the old days, we used things like PS2, serial and parallel ports. They were kind of difficult to configure because you had to actually set up the interrupt request for it. You had to set up the DMA, which is the direct memory access, and the I/O port addresses. With USB, it's pretty much you plug it in and it does all the automatic configuration for you, making it very easy for the end user. You have very rare conflicts now in current systems because Windows handles all of the automatic configurations for you. This is done for you on USB as well as IEEE 1394, which is what we call FireWire. So Universal Serial Bus or USB has replaced all of our PS2, which is a mini DIN connector, serial ports, which are COM plugs, or parallel ports, which are LPT or printer ports. Most of our systems now have USB ports, and most of them have a lot of USB ports. If you don't have enough, you can put in an expansion card that will give you more ports. Or you can use a USB hub that'll take one USB port and turn it into 4 or 8 ports. USB started out, it was version 1.1, which was very slow. They then came out with USB 2.0, which was high speed, and USB 3.0, which is called super speed. And the reason why is 1.1, it had a maximum speed of about 12 megabits per second. When you go to 2.0, it went up to 480 megabits per second. And when we went to 3.0, it went to 5 gigabytes per second, which is also 5,000 megabits per second. So it's much, much faster nowadays than it used to be. If you're using 1.1 or 2.0, they use the same style cable. 3.0 has a better style cable that has a little bit better cladding on it to reduce some of the resistance on it. The higher versions are backwards compatible. So if I have a USB 3.0 port, I can plug in a 1.1 device and it'll work just fine. If you take a 3.0 device and try to plug into a 1.1, it's only going to be able to operate at the speed of 1.1 as well. So all your devices can work backwards. It's just going to go slower based on what you're using. And then we have the ability of doing what's called the daisy chain, where you can do up to 127 devices per port. So if I have one USB outlet on, or one USB port on my laptop, and I plug in a 4-port hub to it, and then I take another 4-port hub and plug it into one of the 4 ports on the original 4-port hub, and then I keep doing that, I can daisy chain it out. I can have up to 127 ports hanging off of one port. So even though you only have one port on a machine, like a lot of the netbooks, you can actually have a lot of devices connecting to them as well as use these repeaters and these hubs to spread it out. So USB types, we have 1.1 and 2.0 connectors. They have the type A's and type B's on the root device or the hubs. The type A is what you actually plug into. That's that rectangular flat one that you plug it into. You can see an example of that up here on the host at the top left corner. Series B is what's used on the devices. It's what actually plugged into your camera or your cell phone or your printer. And then you can see those type B's here underneath where it says devices. We have the standard type B, and then the minis and the micros, and the new 3.0 micro is a different shape connector as well. With 3.0, we have that new S-shaped connector here. As you can see here, this is what you'll see on like external hard drives nowadays. But again, the plug that plugs into the host is still the same. All USB ports are the same on the machine. It's just on your device, whether it's a 1.1 or 2.0, which would be these, or a 3.0, which would be this one. So as I said earlier, our 1.1 devices, they operate at 12 megabits per second. This is good for our storage, our printers, and our cameras. They also have low speed of 1.5, which would be used for your mice and keyboards. That's all part of the 1.1 standard. In the 2.0 standard, we went up to 480 megabits per second, and it did allow backwards compatibility with USB 1.1. And for 3.0, it's super speed USB. It does 5 gigabits per second, and it is still backwards compatible with all the other ones. If you see the high speed logo, they're talking 2.0. If you see super speed or see an SS on the port, like you see here on the right side of the screen, that indicates it's a 3.0 port. So why this is important is a lot of machines don't have all 3.0 ports. They might have 2 3.0 ports and 4 2.0 ports. Like our machines up here, that's how they work. And so usually you'll see them be blue ports, indicate 3.0 as well, and the black ports indicate the older machines, the older ports. But if you're going to plug in like an external hard drive and you have a choice, would you want to plug it into a 2.0 port or a 3.0 port? obviously a 3.0 port, right? Because it's going to go about 10 times faster. And so if you're transferring files, it's going to give you a lot more speed. Yes. If it looks that fast, why does it like take so off the move file back and forth with the thumb drive? So if it goes that fast, why does it take so long to move files to and from the thumb drive? It's not dictated based on the port itself speed. It's the read-write of the device you have. So when you buy a thumb drive, there are different classes of flash storage, which is what is inside your thumb drive. And if you have like a class 10, those are the fast ones. If you have a class 4, those are really slow. And so if you're using like an old 2.0 USB thumb drive, it's probably a class 4 device. See if you're plugging into a new fast port, it's still going to go as fast as that device goes, which is fairly slow. So if you get like the 3-pack for $5 at Walmart, those are usually very slow, low quality ones. Whereas if you get the much more expensive ones, they operate much faster. And so it just depends on the quality of the device you're using. Same thing with the hard drive. Now, if you get a cheap external hard drive versus a higher quality external hard drive, they have different speeds as well. And so it's not the port that's slowing you down, it's the actual physical device you're connected. Yeah. Yes, you multiple hubs. So if you use multiple hubs, do you lose any speed? You can. And so we have two different types of hubs that we're going to talk about. There's what's called a bus-powered hub and a self-powered hub. And when they are, when they actually have their own power supply, it boosts the signal, and so you don't lose the speed. When you have the bus-powered ones where they pull their power from the USB port itself, and you start spreading it out over and over and over again, you start getting a reduction in speed and a reduction in power. The other thing is if you have 127 devices hanging off one port, and you have 4 or 5 or 6 hard drives operating off that one port, they're going to be fighting for access. It's kind of like if you have 5 lanes of traffic going into 1 lane of traffic, they still have to operate. They'll operate that as well. If you operate them all at the same time, you will see some slowdowns. Yeah. So if you have enough ports, it's better to plug it directly to the machine. So speaking of the ports, how do you get more? Here's an example of what we're talking about with the hub. Let's see here we have 2 external hard drives plugged into this. Looks like an 8-port hub. With USB 2.0 and 1.1, if you had a bus powered, which means it's getting the power from the port, from the USB port, they only give you 100 milliamps per port. But if you have a self-powered one, they're getting 500 milliamps per port. With 3.0, they allow higher powered devices, so it goes up to 900 milliamps per port. Why does that matter? It looks like a lot of numbers and electricity. If you ever look at your cell phone or your iPad or a tablet, tablets take more power than an iPhone or than a phone does, right? And so if you're plugging a phone into one of these self-powered hubs where they don't, assuming a bus-powered hub, it's going to take forever to charge because you're only getting 100 milliamps per port. Whereas if you're doing it off self-powered where it actually plugs into the wall outlet to get power, you're going to get 500 milliamps per port. Even at 500 milliamps, if you're trying to power something like an iPad, it's going to take forever for that thing to charge. So if you're trying to charge your iPad, so your computer, you're better off plugging it directly into the computer's port. And if possible, plug it into a USB 3.0 port because they're going to get you more power. It'll charge your device faster. That's usually where this comes into. You'll see here, this hard drive in the picture. If you notice how the cable comes down, it has what they call a Y cable, where it actually splits the cable into 2 pieces. And the reason why is that device took more power than each port individually could give it. So using that Y cable, it can double the power. So about 500 plus 500 should power that particular device. And what I'm talking about is right here. You can see how the cable comes in and then it splits over. This one is being used for data. This one is being used for additional power. And so by using both those ports, it took up 2 USB ports, we gave it enough power for the device to be used. For USB, you want to keep your cables short. The longer the cable is, the slower it's going to go, and the more problems you're going to end up having. So it's recommended that you want to keep it under about 9 feet for the old style and the new style cables. The old 2.0s could go about 15 feet. But essentially, if you keep it 10 feet or less, you're going to have good success. The longer the cable is, its electrical wire inside, it's going to add more resistance, which is going to slow down and cause more problems for you. If you need more ports, again, we can use self-powered or bus-powered hubs. You also can use header tables off the motherboard to add additional USB, or you can use a PCIe X1 slot and buy USB cards. That'll give you an extra 4 ports and put those into your computer as well. The root hub on the computer will support 2 USB ports, and they're connected directly to the host controller on the motherboard. But again, each of those root hubs can support up to 127 devices per port. So 1394, IEEE 1394, affectionately known as FireWire. So when we talk about IEEE, that's the international organization that does standards. And this standard is actually the 1394, that 1394 standard that they have. So you'll either see it referenced as that or as FireWire, which is the common name for it. FireWire is used or was used heavily in Macintosh computers. Apple was a really big proponent of it, as well as Sony. Used very heavily for digital cameras and digital video to transfer data. And it became very popular back with FireWire B, or FireWire 800, which could go 800 megabits per second. This was popular back when USB 2.0 was out. So USB 2.0 could only transfer at 480. This could transfer at 800. So it was more popular for video guys, and they're trying to transfer all that data. It allowed high-speed bidirectional serial transmission to connect PCs to each other or devices. For Macintosh computers, they used it for external hard drives as well as digital video devices. It did allow daisy chaining as well. It could allow 16 devices per port, not the 127 like you could with USB. But again, 16 devices is probably enough for most home users, right? Each device generally had 2 ports on it. It had an in port and an out port. So when you wanted to daisy chain it, it literally would make a serial connection. It would go in one, out the next to the end of the next, and out that one to the next one. And so you could daisy chain them along. Whereas with USB, you had to use these hubs to split the ports. Here, they can actually just do one device to the second device to the third device. Okay? So there's 2 styles of ports. As you can see here in the bottom right corner, you have the FireWire 800, which looks like a big rectangle, and the FireWire 400, which looks more like a D-shaped connector. The FireWire 400 is a 6-pin cable. iLink, which was used on small video cameras, was only a 4-pin cable. It's a much smaller connector. As you can see here in the side of the Sony iLink connector. And then the FireWire B, which is the 800 standard, was the one that had a 9-pin cable that had that big square rectangle. These are just an example of what the ports look like. Again, this is on the side of a digital camera. This was the iLink type connector, the 4-pin. And you can see the daisy chaining going on here from the tower, which is a Mac tower, going to a hard drive, from the hard drive to a second hard drive. The types of devices we would use was hard drives. We would use digital cameras, web cameras, MP3 players, including the first iPods. They actually ran over FireWire before they had their proprietary cable that they used over USB. They did this for high-performance scanners and printers, and anything that needed to transfer large amounts of information, as well as SCSI devices, which we'll talk about a little bit as well. Again, we can do up to 16 devices per port, and they did allow for this daisy chain effect. So SCSI. SCSI is an older technology. We don't use it much anymore. It was used for hard disks, tape drives, zip or jazz drives, which are all forms of tape backup drives essentially. Or there were large capacity floppy disks that were used for backup, scanners, optical drives like CDs and DVDs, printers. And mostly you'd find this nowadays in servers if they're using it for a tape backup system. In old workstations back in the 90s, this was common for hard drives, but it's not very common anymore. In fact, you don't see this hardly at all anymore I don't think I've ever seen it the last 10 years in a commercial application, with the exception of a server tape backup system. Daisy chaining was supported by SCSI. It was a precursor before USB and FireWire was around. We had narrow SCSI, which was an 8-bit transfer, and wide SCSI, which is a 16-bit transfer, which again, nowadays we're talking 64-bit transfers, right? So this is old technology. If it had an 8-bit transfer, it can only do 7 devices off a connector, so 7 in their daisy chain. And for wide SCSI, it could do up to 15 devices in its daisy chain. Each device had to have its own unique number. So just like I have this class that say, okay, Nick, you're number 1, and Charles, you're number 2, and other Nick, you're number 3, and Sarah, you're number 4. And that way when I call people, I would go, okay, number 2. And Charles would go, oh, that's me, and he'd answer up. Each SCSI device has its own unique identifier, and you configure that with either a jumper or a dip switch on it. On this particular model that you see, you can see there is a dip switch, a rotary switch, and it's set to device number 6. Again, narrow had either 3 dip switches or jumpers to be able to identify itself in binary, and wide would have 4 dip switches or jumpers to do it in binary, to be able to address those 15 devices. ID number 7 was always reserved for the SCSI host adapter, which is where you plugged it into the computer, and then everything else was a number based off of that. You can mix speeds with SCSI. There is lots of different speeds available, going from 10 megabits per second all the way up to 320 megabits per second. But again, if you look at USB at 480 or 5 gigabits, it outperforms this bar none, right? And so that's why SCSI is taking a back seat over USB and FireWire because they're faster. And again, if you mix things and you put a 10 megabit device in there and a 320 megabit device, they're going to operate at 10. That's going to always default to the slowest person of the conversation. Serial ports. Again, another device that we don't use very commonly nowadays. These were very, very popular in the early 80s and 90s. In the 80s, this is how we connected our mice to our computers. Okay? The fact that it's serial, what that means for serial communication is that everything transmits one bit at a time. So it's kind of like when we leave the classroom, we all have to go out the door one at a time, right? If we're doing things parallel, we'd have a wide enough door that all of us could walk out at the same time. But in serial, we all have to do a single file line. The way these connectors looked is they were a 9-pin connector. It's called a DB9 connector, which is a D-shaped 9-pin connector. Some really old systems had a 25-pin connector as well, but you're not going to find those commonly at all. The serial cables are actually pinned out specific to the device that they're looking for. There is no real common cable for these. There was no modem cables to connect external modems to them, dial-up modems. But again, no one uses dial-up modems anymore, right? And the modem cables could be used to connect to the external device. The one thing that it's still used for nowadays is what's called a Cisco rollover cable. If you go into the networking side of computers, and you're somebody who's going to be configures routers and switches, it actually connects to your computer using a 9-pin serial cable on one side and an RJ45 network jack on the other to connect to that router or switch. And I'll show you guys an example of what one of those looks like as well. But again, most computers aren't even going to have this port on it anymore. So if you need one of these and your computer doesn't have it, they do make USB to serial adapters. They're about $5, and you plug it into a USB port and it gives you a serial port. And that way you can hook it up to those Cisco devices. The cousin to that is what's called the parallel port, also known as the LPT port. And LPT stood for line printer terminal. Okay, these were printer ports almost exclusively, used for very, very little else. The nice thing about these is they are parallel as opposed to serial. So with the other ones, we can only send 1 bit at a time, right? Here we could send 8 bits at one time. So we're kind of like a wave of soldiers marching together, 8 people at a time going through the door. Instead of sending the 1 bit, we can send 8, so it gets us 8 times faster. The port could be for output only, like to a printer, or bidirectional. And we had the EPP, ECP, or EPB, ECP settings. Again, these ports aren't on most computers nowadays. Almost everyone uses USB for printers now, or networks for printers. So you don't have to worry too much about these. And when I say they were fast, they could operate up to 2 megabits per second, which in today's world is not fast at all, right? But that was fast back in the 80s. And again, this is an old 1980s, 1990s technology. We're just basically showing it to you just so you have a appreciation for this if you run across it in an old computer someplace. Like I said, if you don't have one of these ports, but you have a need for it, maybe your customer has this old $10,000, like chart printer. They don't want to have to replace it, and it only has a parallel port. How are you going to hook it up? Well, you can get a USB to parallel adapter, or you can get an expansion card, PCI or PCIe, and put it in the machine for a couple of dollars. That'll add a parallel port for them, and then you can use it. As I said, Cisco uses the serial one. If you're studying for a CCNA, you're going to get one of these cables. You're going to use it a lot. But as I said, it's serial on one side, and it is RJ45 on the other. It's called a rollover cable. If you have these, you want to enable them in your BIOS to enable the port. If your computer doesn't have one already in there, you can add one using one of these methods. PS2 ports. So again, another thing that is a relic of the 80s and 90s. They were also called mini DIN ports. And these were used for your keyboard and your mouse. Purple was color-coded for keyboard, green was color-coded for mouse. They're not hot swappable, so if you wanted to plug in the keyboard, that means you had to turn off the computer, plug in the keyboard, and turn on the computer. With USB, you can unplug and plug things whenever you want, right? With these, you couldn't. If it wasn't plugged in before you turn on the computer, it wouldn't recognize the keyboard. So you have to do that. And again, they're replaced pretty much by USB at this point, but it is a way that you can still connect keyboards and mice. Your computers here do have, if you look the hydro on the computers at your guest there, they do have those purple and green ports for keyboards and mice if you want to use them. Or you can just plug in USB. Either way will work. The other thing is these are dedicated to the keyboard and mouse exclusively. You can't put the mouse in the purple one or the keyboard in the green one. If you do that, they're not going to work. So if you mix them up, it's going to be a problem. USB doesn't have that problem, right? You plug into any USB port that's going to work. So yeah, USB has made our life a lot easier than it used to be. So another way we do output now is we can do audio, right? You guys want to be able to listen to your music. And there's two different systems that we use for that. We have either the 1/8" audio jacks, which I show you here on the left. They're used for input and output. You can use speakers for output. You can use line in or microphones for input. They are color coded. So if you see pink, it's always going to be your microphone. Light blue is going to be line in. And line in is usually used for something like a music device like your iPod being plugged into your computer. So you can play it through there, or a stereo receiver that you want to plug in through your computer. Something like that. The line green is always going to be your headphone out. Brown is your left to right speaker. And your orange is going to be your subwoofer. So if you have a 5.1 surround sound. So here the picture on the bottom, you can see this integrated rear port cluster. On the right, you can see we have a 5.1 surround sound system with the microphone, the line in, the left and right speakers, etc. The other thing you can have is what's called the Sony Philips digital interconnect format. It is digital audio, so it is a higher quality audio. So if you're a real audio aficionado and love listening to good music, you want to get hooked up this way. And there's two types of connectors we use with that. One is a fiber connector, it's optical. That's the one with the black background. And one is coaxial, which is a shielded RCA cable, which is the one with the white background. That's what those connectors look like. And if you look in the image at the bottom, this orange connection is used for the coaxial SPDIF connector, the Sony Philips digital interface format. And this bottom one here is what's called a TOSNIC connector, which is used for the fiber connector. You just plug this cable into that, and it'll push it in there and allow it to be used. Yes, the fiber optic has a higher quality than the coaxial does, but they're both far superior to the normal audio jack. Yeah. It's very similar, like if you connect your HDMI cable for video versus your composite, the red, green, blue cables. The HDMI is going to be a far superior quality because it's fully digital, whereas the coaxial one has a little bit of analog still to it. For video ports, here's two common video ports you'll find. You have the DVI port on the left, which stands for Digital Video Interface. It provides a high resolution output to computer monitors. It was the first full digital connection for video that we used on computers. On the right, you'll see our 15-pin DB15 15-pin connectors, which is our video graphics adapter. This same port has been used since the 80s. Very, very old port, still found on most computers. It provides analog output to a monitor, to a computer monitor, and it does use a 15-pin connector. You notice my projector here is using that same EB15 connector, as you can see I'm plugged in here. Yes. I've noticed that I keep monitors hooked up because I actually have full books. Yeah, so the question was, how do you get dual monitor setups? If you only have one of these ports, why can't you put two monitors off of it? So with the one on the right, the VGA port, it only supports a single output monitor. So even if you had some kind of like a Y adapter, it doesn't have a strong enough signal to push it to both. They do make a box that can take a single input like that and then mirror it to two displays. In fact, that's what we're using here. So my laptop is going to that box. I then see it on my screen up here at the front and to the projector. You're seeing the same image up there as I'm seeing on this computer screen. But that's a dedicated box that does that. With DVI, some of them can actually be split because they're digital and send out doubles with a special Y adapter that will actually split it to two screens. You can either mirror them or have two different screens. And we'll talk more about that when we get to the video display chapter of how we can do mirroring or extending. And I'll show you guys that as well. When you start dealing with, but usually you're going to end up having either two video cards or video card that has multiple interfaces to support that dual video system. for communications. We have two other types of ports. We have the network port and we have a phone port. A network port is called an RJ45 and a phone port is called an RJ11. And a phone port is just like your standard telephone line in your house. A network port is like you'd see on the back of your cable modem. It's a common port on most computers and they allow you to connect to the network. Most computers nowadays don't have a phone jack anymore because we've gotten rid of dial-up modems. But in the early 2000s, that was on every computer. It was very standard because everybody was trying to get online. Now we all do it over the RJ45 that I'm showing you here on the left. And when we talk about networks, we're going to have an entire lesson dedicated to it. We're going to learn all about these cables, how they're actually cabled, the color codes to them, and how we connect to the internet, how we set up our computers. So we'll get more into those later. So another way we do input, besides our keyboards, is our mice. And our mice and other pointing devices, we can use mice, which is what most people are used to, as you can see here on the picture. But we also have things like the bottom here, which is a trackball. Some graphic artists like using those instead. You also have things like tablets. All of these things give you an XY coordinate to the computer so it knows where you're pointing and translates that to clicks on the screen. They all fall under what's called the human interface device category in Windows. We can connect these by USB. We can do it through wireless, through Bluetooth or infrared. We can do it through the PS2 connector, that green and purple connectors we were talking about before, or even the old serial connectors. If you have USB device, but only a PS2 connector on your motherboard, you can actually get an adapter that will let you connect those together. Same thing if you only have a PS2 device. They make PS2 to USB that you can plug it into a USB port. The mouse always is assigned what's called IRQ12, which is the interrupt request. Again, on modern machines, it's not something you have to deal with very often because Windows handles it for you. On the old systems, we had to actually configure the devices each to have their own interrupt so that they could actually talk at the right time. Our keyboards are the way we actually type our data into the computer. We're all pretty familiar with that, right? The standard keyboard now is a 104 key keyboard with Windows, as you see up at the top right. They can be USB, PS2, wireless or infrared or Bluetooth or something like that. The bottom right is actually a Macintosh keyboard. They do not have the Windows key. Instead, they have this open Apple key next to the spacebar. You can see it kind of looks like a squirrely, it looks like a square with squirrely corners on it. So the reason why it's called Open Apple is actually it'll carry over from the old Apple machines before they went to Macintosh. It actually had an Apple logo on that key. And that's kind of their hotkey for things, like the Windows key is for Windows. Keyboards can have different issues, right? If your keyboard's not working, it could be that your cable is broken if it's a wired keyboard. If it's a wireless keyboard like this one on the bottom, it could be that your batteries are low. If your keyboard has been mistreated because you have children and they get gunk and dirt and food all over the keyboard, or many of us in the office, we sit at our desk and eat because we don't want to have to take a 30-minute lunch break. So we want to leave 30 minutes early instead. And crumbs get into the keyboard, and now every time you try and hit the G key, it doesn't work because you have that crumb of a cracker underneath it. Those are all things that can happen with keyboards. Generally, keyboards are fairly inexpensive. It's an easy replacement fix, especially the traditional keyboard. Or you can get those under the keys and get that out with like a Q-tip or some compressed air. Another input system is what's called a barcode reader. These are very commonly used at point-of-sale systems. So when you go over to Walmart, how do they bring up all your stuff into the computer? They scan the barcode, right? Same thing, right? So that's all these are. There's different ones. There's handheld ones, like the one at the top. There's ones that are pens, or there's ones that are just fixed in place, like at Walmart in the grocery store. Your pen readers are handheld models. Generally, they're going to use either a camera, a laser, a photodiode, or a CCD to actually capture those barcodes. Basically, taking a picture of it for the computer to see it, and they can connect either USB, PS2, stereo, Bluetooth, or infrared. Pretty much like all the other input devices, right? We have lots of different ways we can connect this stuff. Most of the time nowadays, it's USB though. Another way that we can talk to our computers is touchscreen, and this is becoming vastly popular in the last couple of years. Back in the 80s and 90s, it was a very few computers had this type of system or had this type of technology. I had one of the early ones that you can see up here in the top left is an example of one. I worked at a grocery store when I was growing up, and they had a kiosk and they were getting rid of it. It had touchscreen display for the customers to find information about the products. I was like, that's cool. And they let me have it. So I actually got to have one of those early on. Most of the operating systems weren't really made to support these touchscreen things, right? It's very commonly used in a kiosk setting. If you go to the Annapolis Mall, for instance, right, they got those big, like 40 or 50-inch TVs that are touchscreen TVs that you can touch and figure out where you are in the mall and information about the different stores. We've all pretty much played with touchscreens at this point. Your cell phone is a touchscreen display, right? Or your iPad or your Kindle or something like that. They're integrated either into the CRT monitor like the top left or the LCD monitor, LED monitor, or you can even buy an aftermarket attachment like the one at the bottom that would plug in through USB and you'd put it right over the top of your screen. So there's all sorts of different ways they do it. They use either the full wire resistance, the 5-wire resistance, the surface wave, the touch on tube, or skinning infrared are all certain ways they do it. Nowadays, most of the stuff they do are resistance-based technologies. Another way that we can control our inputs is what's called a KVM, or a keyboard video mouse. So where I work, I actually have 3 computers under my desk, as I am for different systems and different classification levels. But I only have 1 mouse and keyboard and monitor on my desk because I don't want to have 3 sets of those. And what I have instead is this KVM. And each of the computers connects to the KVM, and then the KVM will actually switch this mouse and keyboard and monitor to the system I'm operating at the time. So if I push the first button, it goes to my left machine. If I push the second button, it goes to my right machine. And that way I can go between the machines as I need to. There are different ones. They have both PS2 and USB versions that exist. They range from $20 to $30 at Best Buy up to hundreds and thousands of dollars for server-based ones. So it really depends on what you need. There's local and remote versions. The local one is basically sitting on your desk and you push the buttons. That's what I use. Remote ones, or local remote, is where I actually can have one on my desk, but the machines are sitting back in the server room across the hall. And so it just runs wires underneath all the way back to it. And they can be run through Cat5, which is network cables. These can have anywhere from 2 ports to support 2 computers, all the way up to 32 ports or more. If you go to a server rack, generally a big rack like this would have 15 or 20 servers in there. You'll have 1 KVM that includes a keyboard, mouse, and monitor, and you'll push the button to talk with whichever server you want. Because we wouldn't want to have 20 different monitors for this server phone, right? So it makes our job a little easier that way. The idea is one keyboard, mouse, and monitor can support multiple computers. So here's a little bit of review for you guys. This is a rear port cluster, and as we look through all the different pieces to it, right? Up here, we have the mouse connection here because it's purple, right? We have B, which is USB. We have C, which is our fiber link, which is our audio fiber, our Sony Philips digital interface format. We have D is an HDMI connector. I didn't show you that in this video, but that's another video output system. F is DVI. E is our VGA. So here we have 3 different ways to connect monitors. So we could actually, in theory, have 3 different monitors showing 3 different things at a time on here, like you were talking about. G is more USB. H is FireWire 400. This one underneath H we didn't talk about yet. That's eSATA. We'll talk about that when we get to storage. It's how we hook up external hard drives. It's a very fast system. It operates up to 6 gigabits per second. I is our network jack, RJ45. J is more USB. K is our audio cluster with those 1/8-inch audio jacks, right? Here's what some of the cables would look like, right? So A, here we have a 9-pin serial connector. B is a parallel cable. C is a, C looks like a game connector, the joystick connector. D, we are looking at a VGA, 15-pin DB15. E is that DVI connector, again for monitors. S is a keyboard connector. G is a phone connector. H is a network connector, RJ45. And I is a USB. So a couple sample questions here. So after you set up a new computer, your user states that the keyboard and mouse won't work. What do you guys think is the problem? Is the network cable disconnected? The PS2 connectors are switched. The USB connectors are switched. Or the hard drive is unplugged. B, PS2 connectors are switched, right? You can't flip-flop those. The port for the keyboard and the port for the mouse are hardwired for that. With USB, you can switch them all day long. There's no problem. But for PS2, they have to be in the right colored port. Which of the following allows for multiple computers to share display and input devices? An AGP video adapter, a KVM switch, a portable TDR, for a PCI video adapter. B, the KVM, we talked about that, right? We can have 2 to 32 different machines connected to one set of mice, keyboard, and monitor. And the last one, which of the following external ports would a technician use to connect a keyboard? We'll use eSATA, IEEE 1394, VGA, USB, or PS2. Yeah, USB and PS2, right? IEEE 1394, as we said, was FireWire. That's not something we use for keyboards and mouse. Something we use for large data devices, so it's going to be USB and PS2.